Yeah. Oh. Yo, 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 yo. Oh. Alpha, beta, here we go. Learn with ease and let it show. Step by step, we light the way. Success is just a...
Oscillatory motion occurs when an object moves back and forth about a fixed position. In this experiment, a test tube loaded with lead shots is made to oscillate vertically in water. The motion depends on the mass of the test tube and the upthrust acting on it. By measuring the time for several oscillations and plotting a graph of mass against the square of the period, the relationship between mass and oscillation can be studied. Let's get started. You are provided with a beaker filled with water, a weighing scale, a stopwatch, lead shots, and other necessary apparatus. Determine the mass m0 of the test tube provided. So we place the test tube carefully on the electronic balance to determine the mass. And we have 31 grams. We can convert it to kilogram by dividing it by 1000. Introduce some lead shots into the test tube and place it in a vessel of water so that it floats vertically. We are going to depress the loaded test tube a little further into the water and release it so that it will be performing vertical oscillations. And we are going to determine the time t for 5 vertical oscillations. So when we depress it, we release it and start the stopwatch at the same time. And when the test tube moves up and comes down, it will be counted as one oscillation. And on the 5th count, we stop the stopwatch and determine the time t for 5 vertical oscillations. And also we are going to calculate the periodic time t and evaluate the period square. One, 2, 3, 4, 5. So we have 3.56 seconds. And we are going to determine another time for 5 oscillations. We have 1, 2, 3, 4, 5. And that gives 3.53 seconds. Remove the test tube from the vessel and determine the mass m of its content. It's advisable to clean the test tube before determining the mass. And we have 55 grams, which is equal to 0.055 kilogram. That is, we convert the mass from grams to kilograms. So we have the mass in kilograms here, the time 1 in seconds, we have 3.56 seconds, and we repeated it time 2 in seconds, we have 3.53 seconds, and we find the mean time also in seconds, that is 3.56 plus 3.53, and the results divided by 2, which gives 3.55. We evaluate the period also in seconds. The period is the mean time, 3.55, divided by 5, which gives 0.710 to 3 decimal places. And here we are going to square the period. So the period square, the unit will be second squared. So 0.710 squared will give us 0.504. And we are going to repeat the experiment for 4 other increasing values of m. So we add some lead shots to increase the mass. And place the test tube carefully in the water. We are going to determine the time for 5 vertical oscillations for the new mass. 1, 2, 3, 4, 5. So we have 3.72 as the first trial. So we have time 1 to be 3.72 seconds. We repeat it 1, 2, 3, 4, 5. And for the second trial, we have 3.62 seconds. And we are going to determine the mass of the test tube and its content. And we have 58 grams. We convert it to kilogram by dividing it by 1000, which gives 0.058 kilograms. We find the mean time, that is 3.72 plus 3.62, and the result divided by 2, giving 3.67. We find the period by dividing the mean time, 3.67, by 5, which gives 0.734 to 3 decimal places, and we square 0.734, which gives 0.539 seconds squared. We increase the mass by adding some less shots. And determine the time for 5 vertical oscillations. 1, 2, 3, 4, 5, and we have 3.78 seconds. We repeat it again. 1, 2, 3, 4, 5, and we have 3.87 seconds. And we determine the new mass of the test tube and its contents. And the mass is now 62 grams. When we change it to kilogram by dividing by 1000, we have 0.062 kilograms. This is the time for the first trial, and this is the time for the second trial. We find the mean time. That will be 3.78 plus 3.87, and the result divided by 2, which gives 3.83. And we determine the period. That will be the mean time, 3.83 divided by 5, which is 0.766. And we evaluate the period square, that is 0.766 square, which is 0.587. We increase the mass again by adding some less shots. Determine the time for 5 vertical oscillations. 1, 2, 3, 4, 5. And we have 3.93 seconds. We determine the time again. 1, 2, 3, 4, 5. And we have 4.00 seconds. And we determine the mass of the test tube and its contents. And that is 65 grams. We divide by 1000 to change it to kilogram. That will be 0.065. We find the mean time, 3.93 plus 4.00, and we divide by 2 to get 3.97. And the mass is 0.065 kilograms. And the periodic time, we divide 3.97 by 5, which is 0.794, and we square the period. 0.794 squared is 0.630. So we tabulate the results and plot a graph with M as the ordinate, that is the vertical axis, and T square as the abscissa, that is the horizontal axis. So we are plotting M on the vertical axis, but looking at 0.055 is not going to be easy to plot it directly. So we are going to change it to standard form by moving this point 1, 2, 3 and recording this value as 55 times 10 exponent negative 3 kilogram, meaning 55 times 10 exponent negative 3 will give us 0.055. We want to see the values like whole numbers so that it will be easy to plot. So for the next value, when we move the point 1, 2, 3, we have 58. The next one will be 62, and the next one will be 65. And for the values of t square, we also move the decimal point 1, 2, 3, and we record this value as 504. The next one will be 539. The next one 587 and 630. So we draw the vertical and horizontal axis, and we are plotting M on the vertical axis. So we have M slash 10 exponent negative 30 kilogram, and we are plotting t squared on the horizontal axis. So we have t squared slash 10 exponent negative 3, and the unit is seconds squared. So we choose a scale. We will choose a scale of 2 centimeters is to 2 times 10 exponent negative 3 kilogram on m axis. When we look at the values of m, the least value is 55 and the highest is 65. And the question did not tell us to start from the origin 0, 0. So we can start from 50 and keep on adding 2. So we have 52, 54, 56, 58, 60, 62, and so on. And so we will get our values 55 to 65. We will get all of them here. And for t square axis, the least value is 504 and the highest is 630. So we can choose a scale of 2 centimeters is to 20 times 10 to the negative 3 seconds square on t square axis. So now we can start from 500 since the least value is 504, and we keep on adding 20. So we have 520, 540, 560, 580, and so on. So meaning we will get all the values from 504 to 630 here, since the question did not tell us to start from the origin. Now for the first point, we have 55 on m axis. This is 54 and this is 56. So the middle will be 55. And we have 504 on t square axis. On t square axis, the difference between each big box is 20. And when we divide 20 by 10, we have 2. So it means each small box on the horizontal axis is equal to 2. For 504, this is 500. And one box is 2. So we have 502 and 504. That means 500 plus 2 more small boxes. So they will meet here. For the next value, we have 58 on m axis. This is 58. And we have 539. This is 540. So 539 will be within the last box. So they are going to meet here. The next one, we have 62 on m axis and 587. This is 580. One box is 2. So 582, 4, 6, and then 7 will be in the next box. The next one, we have 65. This is 64, this is 66, so the middle will be 65. And we have 630. This is 620, and this is 640, so the middle will be 630, and they are meeting here. And we draw the line of best fit. Determine the slope S of the graph. So to draw the slope, draw a horizontal line meeting the line of best fit. There is no specific point to draw the horizontal and vertical lines, but make sure the slope is as big as possible. And we draw this vertical line, forming a triangle with the line of best fit. We name here A, here B, and here C. And the slope is going to be change in BC over change in AB. For change in BC, we have C minus B. And here, remember, the difference between each big box is 2. And 2 divided by 10 is 0.2. So we have 66. One small box is going to be 0.2, 66.2, 66.4 minus for B part, we have 56. Remember, on the vertical axis, we change it to standard form, so we have times 10 to the negative 3 kilogram. So that is C minus B. For the change in AB, we have B minus A. For B, we have 640 minus here one small box is going to be 2 over here. The middle here will be 5, 10, so 5, 12, 5, 14, 5, 16. Remember, on the horizontal axis too, we changed it to standard form, so we have times 10 to the negative 3. And don't forget to bring the unit second square over there. So now we can cancel out times 10 to the negative 3. And here 66.4 minus 56 is 10.4. And the unit is kilogram. And 614 minus 516 is 124. The unit is second square. So 10.4 divided by 124 will give us 0.084. We have kilogram at the numerator and second square at the denominator. So the reciprocal of second square will be per second square. So the slope is 0.084 kilogram per second square. Thanks for watching, and don't forget to subscribe for more updates.
Oh, alpha, beta, here we go. Learn with ease and let it show. Step by step, we light the way. Success is just a click.